Good evening, and welcome to this evening's TI Technology webinar hosted by Texas Instruments, where tonight we're going to take a look at doing some data collection with TI-SmartView CE. I see that many of you are joining us for the first time, so we'd like to offer a special welcome if this is your first T-Cubed Professional Development webinar. We'd also like to thank everyone for completing the live survey on the right side of your screen. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make those tough to teach, tough to learn concepts accessible to all my students. I'm really excited to introduce our two panelists tonight, Judy Day and Jackie Bono. Judy is a former middle and high school teacher of life science, biology, marine ecology, and earth science. She worked for 14 years with the Science House at NC State University, assisting teachers in incorporating technology into their teaching. She currently is the Associate Director of the Office of Undergraduate Research at NC State University, but continues to instruct teachers and students in science technology as a consultant for Vernier Software and Technology and a T-Cubed National Instructor. Judy is also the Director of the NC Science and Engineering Fair. Thanks so much for being with us, Judy.
Thank you. I'm looking forward to the evening.
And Jackie taught for 37 years, primarily chemistry and physics. She is currently retired and also consults for Vernier Software and Texas Instruments. Jackie is the author of the TI Forensics book. Jackie, thanks so much for being with us.
Thank you. I look forward to an evening of fun and adventure.
We're expecting a large crowd, so your audio is muted. Feel free to send questions to Judy or Jackie using the Q&A window on the right side of your screen. As a reminder, this session is being recorded, and at the conclusion of the event, we'll be providing you with a certificate of attendance, as well as a link for the documents that Jackie and Judy are both using tonight. We hope you don't have any audio issues, but in the event that you do, try selecting Communicate in the WebEx menu, choose Audio Broadcast, and then click Join. At this point, Jackie is going to discuss our agenda.
Hi, everyone. Tonight we're going to be doing some data collection with the TI-SmartView CE, and for that reason, we're going to choose to do 3 activities, and the 3 activities that we're going to do are going to feature data collection using multiple runs, and for that activity, we'll be doing one of Vernier's activities that many of you may have seen called evaporation of alcohols. The second part, or the second activity that we'll explore, is a life science activity where we're going to capture screenshots and create your own labs using the biology lab called Transpiration. And the final activity is one where you actually don't use sensors, but you manually enter data, and it's a lab out of the biology in the 84 or 83 book from years ago called Like Moths Around a Flame. After the 3 activities that we hope to complete in the time we have, we'll join back again, and we'll talk about those online resources that are available free to all of you, and there will be a giveaway at the end of the conference, at the end of the meeting for the TI International Conference.
Thanks so much, Jackie. And Judy is going to discuss our expected outcomes.
Yes, Jackie's already referred to some of this. We really are going to look at how collecting and analyzing data with the sensors in the TI-SmartView CE is a little bit different than collecting data with the TI-84 that you may have used in the past, because the interfaces are a little bit different from what you have to use. We're going to be looking also about how you can create your own lab and incorporate screenshots by using the TI-SmartView and make graphs of the data that you collect to be able to share with your students. By doing that, you can make it a dynamic labs that have the screenshots on them. You can create worksheets. You can also have the history of the keystrokes in case you have students that need that extra support to be able to catch up or to follow along.
Thanks so much, Judy. It's all yours.
Okay, and talking about the setup for the data collection, depending upon whether you're using a computer for your setup with the SmartView or whether you're using the TI-84 CE, you need to use different interfaces. For the computer, you'd be using the USB connection, so you would want to use the Go link or any of the Go sensors like the Go temp or that have the USB connection on them. If you're using the TI-84 CE, since that only has the mini USB port, you would need to use the EasyLink or some of the EasySync sensors that are out there to be able to connect in. With this, you don't have the CBL to be able to connect into or a lab cradle, so you're actually powering the sensors from that 84 CE. So you do have to look at which sensors pull a lot of energy when you're making your plans. So I'm going to pass that on to Jackie and let her tell you a little bit about what she's up to this afternoon.
Thank you, Judy. And I'm going to actually be using one of those sensors that plug directly into the CE or to the computer in our case. The big difference being the size of the USB, and there are adapters that go back and forth. So I am actually going to be using a Go temp and 3 alcohols. The interesting thing with this activity is the activity actually will be given to you at the end of the webinar, so you can actually have a printout of that. And I need to bring up my CE here. So this is SmartView. You should be seeing my screen hopefully right now, and you're seeing TI-SmartView. And the application that I'm going to be running is called Easy Data. It was written by Vernier, and all apps are found in this app key. So I'm going to go to Apps. I'm going to choose Easy Data, which is right here. It may well come up automatically. If it doesn't, this is what we have to do. We have to open it. And it should note that I'm reading temperature, and the temperature is being read in degrees Celsius. Good lab technique tells us that we always start a new document, and the reason for that is that if your calculators or computers were used previously with other sensors, you want to make sure you're back to the default that was done by the company. And in order to hit these tabs down here, you can't touch your screen to do that in TI-SmartView. You need to touch the soft keys, which would be beneath them. So in order to do a new load, you hit File, New, and all it's doing is checking the sensors and resetting it back to the factory default. That's going to save you a lot of time if kids are doing this on their own calculators, in that you won't be troubleshooting one after the other. I'm now going to change the time setting, and I'm going to change the time setting to collect data for only 30 seconds. And the reason for that is that alcohol evaporates very quickly, and I don't need the 3-minute default. So temperature sensors always have a 3-minute default. I want something other than that. So I'm going to change the setup. I'm going to change the setup by pressing the setup key, and that's the window key, Windows soft key. I'm going to go to time graph, and I want to change it, so that's edit, and that's the zoom key. All right, I'm going to stay with 1 sample per second. I'm going to press next, and I'm going to go back and change that to 30. Oops. Let's go to clear and type in 30. So I'm going to collect data for 30 seconds. I want to say next by pressing the zoom key. Notice everyone should look like this if you're following along and trying to do it yourself, and then press OK. So it's 30 seconds, 1 sample per second. Notice on my screen now it says 30 seconds. This lot's not really difficult. I currently have the temperature sensor sitting in some methanol. So I'm going to start data collection by pressing the zoom key. That's what the start is. And we'll take it out, I hope, and let it evaporate. And the physical setup that I had is the setup that was on the slide, which I'll go back to and show you in a minute. But I basically have a temperature sensor, and I have a piece of filter paper around the tip of the sensor, and it's attached with a small elastic. And the best elastics you can find for this are actually elastics that some of your students will have for their braces. Now you'll notice what a nice line that is. Notice that it auto-scaled all by itself. I now am going to change the filter, and when I filter paper on the end and use a different alcohol. Before I do that, I have to remove the first, put on the second. Just give me a minute. I'm trying to talk on the phone and do this at the same time. And so what I need to do is I need to save this run. And to do that, I need to go back to the main screen. So to hit main, I'm going to hit the graph key, go to File, and I'm going to store my run. When I store my run, what it's going to do is it's going to move the data from one list to the next. So initially, the time was in list 1 and temperature was in list 2. Now it's taken what used to be in list 2 and moved it to 3. Time is going to remain in list 1. All right, I'm going to do propanol. You can do several. I'm just going to do a couple here to show you what we want. I'm going to click OK by hitting the graph key. Notice I'm kind of warm right now. When I hit Start, it's going to tell me that I'm erasing my data. And I really don't care because I've moved it. So I'm going to hit the Zoom key. And as it's going to overwrite it, I'm going to say that's fine. If I hadn't moved it, I would have lost it right now. I'm going to get a couple of data points, and I'm going to take it out and let it evaporate. So the first alcohol I used was methanol. Now I'm using N-propanol, and I'm going to see if there's a difference in evaporation rates. Application is several places, one of which is in chemical properties compounds. Another one is you could use it to identify an unknown. There's a forensics lab that does that. You could talk about molecular weight. You can talk about bonding. You can talk about comparing alcohols and water. And this is an interesting graph. I don't know where my graph is. Oh, I put it on the sink. Okay. So let's just see. What I'd like to do is see both graphs at the same time. And in order to do that, I'm going to go to Advanced. And I want to see list 1, which is time. I want to see list 2, which is my propanol. And I want to see list 3, which is my methanol that was moved from 1 to 2. So I want to do number 6, list 2 and 3 versus list 1. So I'm going to press 6. When I do that, I'm going to see both graphs. And you know what? I'm going to redo my last graph. Let me redo my next graph. My last graph was a problem, so I'm going to just redo it. I'm not going to store that run. I'm over here, and I'm going to start again. And it's going to overwrite. I don't care because that's the one That's the one I want to overwrite. Okay, I'm at 21. Let me take it out. See if it goes down better. The problem is that I'm working in the bathroom to do this, and I put it on the sink. So it didn't go down as much as I would like. Again, there's a lot of applications to this evaporation rate for folks. It's important that I don't stop it because the list must be of both the same length. Now I'm going to go to Advanced, and I'm going to go back down and see those two. And you will see both graphs at the same rate. And what you'll notice is that the blue, which is the propanol, evaporated much slower than the pink, which is my methanol. And I can take and analyze that data and actually get the slope of those two graphs and see that. So if this were a middle school lab, you would quite simply ask the kids to take the high point and the low point and figure out the rate of evaporation. In this case, we're going to actually go through and analyze, and there's a nice analyze function right down here. So if I hit Zoom, I'm going to say linear fit. Oh, I'm going to have to choose my plot first. It's going to ask me to choose which one I want. I'm going to say OK. So I'll go back here, choose my plot, choose time versus temperature. This is the one. I'm going to analyze it, and I'm going to do linear fit. It's performing the calculation. Notice that it gives me a slope. Notice that slope is negative because it is the temperature is going down. It gives me an R value, which isn't too bad. I could have, in fact, selected a region of that and done that as well, depending upon the level of the student. So this is it. Notice it draws a pretty nice line through that for me. I then can take and analyze the second one. And in order to do that, I'm going to go to Advanced, and I'm going to do 1 versus 3. There we go, it's that one. And this time, because the graph is so flat here, I only want to analyze this part of it. So when I go to Analyze, I'm going to choose a section of the graph. That's number 7. And it's going to delete my data, and I know that. It's pretty powerful for the kids when they see those two graphs at the same time. When I get to the point I like, by using my side arrow, I'm going to hit Enter. It's going to draw a line for me. Notice the arrow is now on this side. I'll just come in 1 or 2, hit Enter. It's performing the calculation. I'm going to go to Analyze, Linear Fit. Notice now the calculation is 0.2. The previous calculation was 0.03, so the evaporation rate was much greater the smaller the molecule, and we could talk about the science behind that. But I think students seeing that graph generated in front of them is very powerful. If you only have one sensor and you want to demo that, you have a young group, you want to demo it, it's very helpful to do that. And now, I'm going to stop sharing this for a moment. And you'll notice on the next slide here, this is the physical setup, I hope. Okay. Get this to go to 9. This is the This is the physical setup that I have right here. This is the temperature sensor. This was the filter paper and the elastic holding it. So I'm going to now pass it on to Judy so that Judy can give you the next lab that we're going to go over and some of the other features of SmartView. So Judy, it's coming to you.
Okay, so Jackie's told you a little bit about the data collection using the temperature probe. Those of you who are biology people or life science people know a little bit about what transpiration is. The rest of you, when you're talking about transpiration of a plant, you're talking about the movement of water through the roots, up the stem, and out through the leaves, and then out through the stomata. And you can actually measure that and looking at the number of stomata, all that kind of things. And different plants have different rates of transpiration. And plants have that movement of water at different rates depending upon different conditions that the plant is in. If it's in too windy of an area, like if Matthew was coming through, all those stomata would close down to preserve what moisture they have. If it's too hot, they close down to try to preserve moisture in the water and that type of thing. So you will actually be getting copies of all of these activities that we are talking about and that we're working on at the end of the webinar, so for you to be able to look at and see how we are doing these. So I'm going to be talking a little bit about how you can take a lab that is already there. You can add the lab in on a sheet, on a document, and incorporate screenshots that you're taking while you're collecting the data. So I'm going to go and look at the keystrokes. So I'm going to go in and see if I can pull up, where is it? All right, my SmartView. I've got mine set up a little bit differently so you can see on the right-hand side.
Hey, Judy.
Yes, I didn't.
Share your desktop, yep.
Okay, you have to talk to me about this.
So at the very top of your screen where there's like File, Edit, and then there's Share.
Yes, and once I get into this, you have to remind me of these things. All right, do you have it now?
It's coming slowly. There we go. Yep.
There we go. Okay. All right. Thank you. You need to speak up. Okay. All right. So in looking at the SmartView right now, the way I have it set up is so you can see the calculator screen, so you can see the larger image of the screen itself beside the calculator. Then I've got the key press history below, and to the right-hand side is where I'm going to have any of the screenshots pop up that I'm going to be taking. So I'm going to be using the veneer gas pressure sensor, and I'll tell you about the setup while it's actually collecting data. I'm going to go ahead and start my apps the same way that Jackie did, and I'm going to go to Easy Data, and it will go through and set itself up, and it should come up saying that it has a gas pressure sensor. Now right now it's reading the gas pressure of my room air, and I'm getting ready to connect the tube that has water in it and that's connected to my plant to my gas pressure sensor. So when I do that, you'll see the gas pressure will jump. Okay. So now that is set up. Now, usually people will collect data for this activity for around 10 minutes, but to save time, we're only going to be doing it for around 5 minutes or maybe even a little bit less so you can see what's going on. I do want to change my setup, and it's a good idea to get in the habit of whenever you start a new sensor to go ahead and to go to File and then select a new setup, because right now it has another setting. If I go to File and One New, it goes out and checks the sensor that's plugged in and comes back with the default settings for each sensor. Any of the sensors that have a little white plug-in have a default way of collecting data that will come up, and if it works for you, all you have to do is hit Start. If it doesn't work for you, then you need to change the setup, which is what I'm going to do tonight. So I'm going to go to the setup, which is actually my window key, and I'm going to still do a time graph. Number one is showing me the sensor that I have plugged in, which is my pressure sensor. So if I select number 2 for time graph, these are the settings that are the default settings for the gas pressure sensor. I don't want to collect 15 minutes worth of data, which is what that default is. I want to edit that. So I'm going to use the Edit, which is actually the Zoom key if you're pressing. I will leave the time between the samples and for 10 seconds so that we won't have quite as much data to analyze. So I'm going to hit Next, which is also the Zoom key. But instead of collecting 90 samples, I'm going to change that to only 30 samples. So if I do 30 samples and say Next, that gives me 300 seconds for my experiment length, which is 5 minutes. So that works for me. That's what I want to have. The settings are correct. If I had typed something in incorrectly, I could go back to my Edit key and change it. So I'm going to say OK, which is hitting the graph button. So now I'm back up to what looks like the home screen, kind of for my Easy Data software for the app. And you can see that my gas pressure is being read in kilopascals, and I'm all ready to get started with my data collection. Now, you may notice that it is collecting the gas pressure live, and it is slowly dropping. So I'm going to go ahead and start my data collection, which is my Zoom key. And you'll see a dot coming up every 10 seconds, and I'll wait until we get a couple of data points there. And you can see at the top of the screen what the gas pressure is actually reading and how it is decreasing over a period of time with each data point. So I'll wait till the next one. Okay, there we go. It's going about 6/100ths of decrease. So since the screen isn't zoomed in right now, it doesn't look very impressive, but it's still dropping. Okay, so if you would like to do this activity, there are a few tricks to make it work correctly. And the first thing is if you did this lab years ago, you would have read about growing seedling plants or growing tomato plants. Those all have really soft stems that collapse. So through the years, I've discovered if you want to have good results, the best thing to do is go trim your shrubbery, or find a tree, or find a bush that has a woody stem that is a round stem. It can't be one of those that has ridges on it or lots of bumps or is squared off like some of the stems are. So you want one that's round. I usually take the tubing that comes with a gas pressure sensor with me. While I'm trimming my shrubbery, I just take my clippers with me and a cup of water and stick them down in the water right away. And I compare the size of the stems with the tubing because it's kind of like hair. You want something that will just be a little bit bigger than fitting, because you can always trim it a little bit to fit. But if you get one too small, you can't glue it back on and make it bigger. So you want to set it up. You will either do it underwater and fill that tubing up with water, or fill it up with a syringe and carefully put the stem down into you'll take one of the little white tips off of the tubing, and where the end that you took the white tip off is where you'll stick the stem for your plant. Along with your gas pressure sensor and the little kit of supplies is a little white clip. And if you'll put the little white clip on the top of the tubing around the edge of the stem and squeeze it, it will give you a little bit tighter connection. Then hold it upside down. If you see any water coming out of the stem, or if you have an air bubble next to the stem in the tubing, you need to get the air bubble out or make that connection tighter along the way. You can actually mark the level of the water on the other end nearer the gas pressure sensor, so that as the water is being pulled into the plant, you can measure it, mark where you started, where you ended, and then go back with a syringe and actually calculate how many milliliters of water or cc's of water were drawn up into the plant. So you can see we're still dropping along the way in pressure. The leaves that I usually like to get are not the waxy leaves, because they tend not to lose as much moisture. They have that waxy coating trying to protect them. So while we're looking around and waiting for my time, the screen over here to the side is where my screenshots, and I haven't taken a single screenshot, so let me do one right quick. So there's my data being collected. And I can actually arrange how I want my screen to look by the tabs up at the top. And as soon as we get through with that, I'll do another screenshot. When you get the handout, you'll see that I have screenshots all the way through of how to change your time settings and how to do what the graph looks like when you start, what it looks like when you get through, and along the way. Sometimes I get to talking and I forget. I agree that I like real life better, so to see it happening. And I would stop this since it is dropping nicely, but I would like to show you what the next run looks like. But if I do that, we won't be able to compare. Actually, I think we're just about getting there. You notice that we're using if you have not used the Easy Data app before, the commands on the Easy Data app correspond to the keys that you have right underneath the window on the screen. So the stop button would actually be my zoom button. And we're almost there. As soon as we get through with the data collection, it will auto-scale, and it will look a lot more impressive as to what's actually happening. There we go. So I'm going to take a screenshot of that one because it's a nice graph. You really get nice linear graphs with this one. And what I want to find out now is, if you're in math, you're going to say, I want to find the slope of the line. If you're in biology, I want to find out what the rate of change in pressure over time was, or decrease in pressure as the water was being pulled into the plant. So I'm going to first go into Analyze. And I think it's always a nice idea to find out what your statistics are. So under Analyze, the first option you have is if one, which are the statistics. So I'm going to hit that, and it's going to ask me to select what area of the graph I want to get the statistics for. Well, I'm going to select my left bound and say OK, and on the graph key. And now it comes up with my right bound, and I'm going to say OK, because I want the entire thing. And I'm going to take a screenshot of that, so we'll know what my statistics are. Notice I've got 31 data points because it collected one data point at the very beginning and then all the way through. So I'm going to say OK to that. Now I want to go in and actually find out what the rate of decreasing pressure was, or what the slope of that line was. So I'm going to go back to Analyze, or hit my Zoom key, and I'm going to select 2, which is a linear fit. And there it is. So you can see that my R value is very close to -1 at 0.998, which looks pretty good. But my slope is decreasing, and my y-intercept is the value that we started off with. So once I hit OK, you can see how close the data actually is to the graph that I collected. Now, someone was asking about how did I get the screenshot. If you'll look up at the top of the screen and see the little camera that's up at the top, I can hit the camera, and that will give me my screenshot. And then I can save these screenshots to be able to incorporate whether I want to use it for a test, whether I want to use it for a worksheet, if I want to put it in a lab that I'm developing. I have lots of different options. I also have the key press history. And remember that key press history is referring to the key names that are below the screen, not the names that are on the actual window itself. So once I have done that, I can go back to Main. And if I want to do a second run, which usually this is your baseline or your control at room temperature. So I would change something like maybe misting the plant and putting in a plastic bag and seeing how high humidity would change the rate of the water moving out through the leaves. Or I might put a grow lamp on top of it and see if I increased photosynthesis, if it would be pulling more water through to be able to help with that photosynthesis. Yeah, I can't talk. Photosynthesis process. Or I could hit a fan on it and see how much wind it would take. Gentle breeze would cause it to lose water faster. Really strong breeze would close down the stomata. So if I wanted to do a second run, I would hit go back to my file the same way that Jackie did, and I would go 5 store run. So it's going to do the same thing that Jackie did with her alcohol data. It will move everything that is in my L2 and to L3. And if I had something in L3, it would move it over to L4. So that's exactly what I wanted to do. So I'm going to say OK. Now, if I wanted to do a different run or a different setup and fan the plant, now I'd be all ready to go. I would just have to change my condition and be ready to start my data collection. There's one thing you need to do. As time progresses, it gets harder for that plant to pull against the gradient. So before you start your second run, you would open up the gas pressure sensor. Notice that it changed. And then connect your gas pressure sensor again. And it went up higher this time than it did last time. And wait until I see it that it equivocate. Oops. And I would go ahead and start my data collection again for the second run. So it's really important that you undo the gas pressure tubing from the sensor and then reconnect it so that you're starting off at the same baseline instead of having to pull about against a deeper gradient. So that's pretty much how that works. I can go into, again, the screenshots that I have made and use these for various things that I may want to incorporate them in activities. I've got my key press history of my data collection that's here to be able to give the students. So I'm going to go ahead and pass this over to Jackie And she's going to talk to you about another way of not actually collecting data live, but analyzing data that we have already collected. So let me see if I can send this back over to Jackie. And I think you should have it.
I do. Thanks a lot, Judy. So Judy mentioned all of the stuff that she showed you, the screenshots, which is really, really very useful. The interesting thing is all of that is you just take and paste it into Word and do any kinds of formatting you want to do. One of the nicest things that I find about the screenshots that I've taken and written into documents is in my Word document, I typically make a table, and I put my screenshots on one side and then the text that goes with them on the other column, and that gives me a better formatting. Otherwise, I was having some issues. But they are actually pictures. You can size them as you want, and the keystrokes you literally cut and paste if you want to tell kids how to push buttons and you don't have the screen in front of you. The activity we're going to do right now is like moths around a flame, and it is actually just pulled off of the TI website, and you will have access to this at the end as well. And I'm going to share my desktop with you for a moment. Okay, I think. And this is, again, the TI-SmartView that we've been talking about. And what I wanted to do is something I didn't do last time is, I collected all this data, and it was really good data, but sometimes people want to know where that data resides. And we're actually going to clear out that data to do this activity. And I'm going to do something slightly different. I really like the big screen to project, but sometimes what we find is if we have the side screens here, students can see other things as well as I go through. It does compromise the size of the screen as the history, but there are some other really positive things over here. So this is actually the last data that I had. If I want to see where all that data is, if I press the Stat key and I hit Enter, so as to edit it, this is all of the data that we just did for the evaporation of alcohols. That's where it resides. And you can do anything you want with that data once it's there within the calculator, any kind of manipulation you want. I actually need to clear these lists to do this next activity. There's more than one way to clear a list. So one of the ways to clear a list is to take your arrow, go up to in the L1, L2, L3, hit clear, and hit enter, and the list goes away. An easier way some people think to clear a list is to hit second, mem, and one of the things is clear all lists. So I'm going to clear all the lists, and then you must hit enter, and it will say done, and your lists are cleared. If you don't hit the enter, it will not clear the list. So now when I go back to my list here, you'll see all of the lists are cleared. Now, there's some data that I'm going to literally hand enter, and it has to do with an environmental time where we were actually burning coal and we had some moths. And I can hand enter all of this data literally by typing it in if that is what I wanted to do. That would kind of be a pain in the neck to do during class time. So what I actually did beforehand is I came and I actually did all of this. So I'm going to just enter it. You could hand enter it if you want to, or in my case, I'm going to just load it up, so to speak. So to do that, I'm going to come here, and I'm going to go to 8. Oops, 8. And I'm going to ungroup it, hit enter, and I'm going to overwrite everything, I hope. And I'll write that as well. And I don't have anything. Yes, I do. I'm going to overwrite that as well. Should have done overwrite all, and I would have been all done. Okay, and now when I come back to my list and hit enter, all the data is entered. So I hand entered this data previously. I'm just going to put it in the list now for you to see. Once you have hand entered the data into your list, the interesting thing, of course, to do is to see that. data. And to do that, you have to turn on your stat plots. You have to turn on your graphs. So to do that, you hit second, y equals. I need to turn stat plot 1 on. It is on, but I'm going to go through the steps anyway. I'm going to go there. It must be on. I hit enter to make sure it's on. I want it to be a scatter plot. I want to graph list 1 and list 2. So this is list 1 is going to be my x. List 2 is going to be my y. So to get list 2, you'll notice over the number 2 in blue is L2. So I hit second, 2, change that to list 2. Then I go down and choose the symbol I want. So we'll choose that symbol. That's kind of a nice symbol. You can choose any that you'd like. Nice thing on the CE is you have the color, and over here you can use these arrows to change the color of the line to whatever you would like it to be. So I'm going to hit enter. And now I have to turn on plot 2 because here I'm doing list 1 and list 2. I also want to graph list 1 and list 3. So I'm going to go up to plot 2, hit enter, make sure it's on, and it is. I want this type of graph. I want it to be list 1 and list 3. So again, L3 is over the number 3, so it's second, 3. Come down, and I will use this symbol for this one. Come down again, and you can choose a different color. My last color was navy, so this time I'll choose something bright like magenta and hit enter. And when I hit graph, I don't see it. And of course, the reason I don't see it is that my data range isn't what's on the graph. So if you wanted to, you could have your students go back and look at that data, which is, don't do that. I don't want to do that. Okay, second click, go back to here, hit enter, and you'll notice that my data here is 1860 to 1960. This is, between 90 and 20, and this is between 10 and 80. So basically, I'm between 1 and 100 for list 1 and 2, and I'm between 1860 and 1960 for list 1. If you wanted, your students could choose window, and you could have them do that. As a science teacher, I oftentimes do Zoom 9, which is Zoom Stat, and it chooses it for me, and it will graph the data. Now, this is a situation where someone actually went out and counted the number of light-wing moths and dark-wing moths, and they took the percentage of each over these years, and it ties into the Industrial Revolution and the fact that animals can camouflage themselves, and if they don't, they will become more of a prey to other animals. So it's an application that ties into the environmental area. It's an application that sort of ties in to survival of species, those kinds of things in the life science area. But the idea of hand entering any data you have, and in the chat a little while ago somebody talked about that, the idea of doing any data you have is pretty powerful. Now notice that my graphs on the side don't reflect that, and that's because I have to refresh them. And once I refresh them, you can see that you can see an equation that's in there, you can see the graph, you can see the data table, while you're also seeing the big screen of what you want to see. You can also change what that big screen is, and the other information is available to you. I'm going to go back for a moment, stop sharing my screen for a moment. And I think that what's important now is that if you have any questions, that we answer those questions. I need to say one of the things that's on this that really didn't hit was this idea of SmartPad, and I use SmartPad when I present to kids or when I present this information to adults, because what it allows me to do, it's an application that resides on my TI calculator on the CE, and it allows me to use the calculator keys to push rather than pushing the keys on my computer. That's really important for me so I can easily face the kids and interact with the kids, not looking at my computer screen. It gives me the feel of the button pushing that I'm asking kids to do. So that's something else that you need to look at. You would have to download SmartPad, and then it simply drives your computer. And as a teaching tool, it makes SmartView a little bit more interactive with students, and I think that that's kind of interesting. I noticed that somebody said that was a really nice logistics curve, and it was, and I didn't I didn't get that function. You could analyze that function within the calculator, obviously, as well. So I'm going to turn this back over now to Michael, and Michael has some things to do.
Thanks, Jackie. We did have a question from Kim. Her question was, she wanted to know if your pictures just store, or did you screenshot them every time?
When I'm making a document, I go through and I run the whole lab myself, and I screenshot as I go through, and you can store them. You can save them from shutting down and save them later. And then I make my document after I've gone through the whole thing. I don't bounce back and forth between Word and. I tend to do the whole lab and go from there.
And I agree with that. I run the lab and take screenshots as I'm doing the lab. Tonight I was trying to talk, and you can't do everything at the same time, especially when you're as uncoordinated as I am. But when you get the handout, you can see it starting from the Easy Data screen through all the different steps that you go through. And I just run the lab first and pull the screenshots that I want students to be able to see. And once I do that, then I can save them and use them as I need.
And I use them, by the way, excuse me, not only on labs, but I would also, for example, that logistics curve that we just saw, you could easily put that on an exam and ask the kids to analyze that on an exam, or ask the kids what this shows. So its application isn't necessarily just for a lab. It could be for a worksheet, it could be for an exam, it could be for anything else that we want the kids to take a look at it. I find also the other thing is the key history. I find that kids, if I copy and paste that into Word, kids sometimes have an easier time following what I'm doing if they have it or at home if they have that in front of them. So it's another nice tool to be able to give kids.
And we also just had a question from Eleanor. She was trying to connect up her CBR2 to her laptop, and so she wanted to know if she uses the printer cable.
Can't connect a CBR2 to her, so she has to use, her CBR2 has a mini USB, and she needs a big USB to plug it into her computer. So there is a $5 connector that's sold by Vernier, and you used to be able to get them in Radio Shack, which will make her mini USB from her CBR2 become a large USB that will go into her computer. She also could contact Vernier, and Vernier would give her, she could buy, and I want to say it's a similar kind of price, a different cable that would plug into the CBR2 but would have a big USB for her computer.
And then, great, and then so if she were to get that adapter and plug everything in, would she just use just a regular Easy Data app?
Yes, she would.
I saw Pamela was asking, she's got a new classroom set of 84 CEs, but some of her CBRs won't work with all the calculators.
CBRs should work with her calculator.
Right, that's what I was thinking.
Yep.
It should, the mini USB, as long as she's able to plug it in with the mini USB, that should work.
Yep. Her CBLs won't work with her calculator. But
exactly.
CBRs will. Yes.
CBRs will.
If they don't, then that may well be a Vernier question, because that should not be that's not a calculator problem, and a call to Vernier may rectify it. It also could be that the CBRs do have batteries. It could be any number of problems.
So it might be good to call Vernier and ask them to help her troubleshoot.
I would say yes.
I know earlier, Judy and Jackie, the three of us were talking about providing participants with your email address. So if you're comfortable doing that, go ahead and put that in the chat window.
Okay.
And so if you have some questions tonight that didn't get answered for one reason or another, I think we tried to answer all of them, or you have any questions after the webinar, please feel free to jot down Jackie and Judy's email addresses, and feel free to reach out to them. They have a ton of experience with TI-SmartView and data collection and just teaching science in general, so I know they'd be more than willing to lend a hand.
Okay, the difference between the CBLs and the CBRs, the CBRs are motion detectors. The CBLs have the connections on the top and the sides to be able to plug in multiple sensors, and those will not work with 84 CEs. So hopefully that will help clarify that.
Great. I do want to share some resources that are available on our website, which is education.ti.com. And I believe Harriet had just asked a question a few minutes ago about the first probe that was used. That was, I believe, the Easy Temp. You guys can correct me if I'm wrong. And
can you ask that question again, Mike?
Yep. What was the name of the first probe that was used tonight?
It was if it was going into the calculator, it would be an Easy Temp. I was plugging into the computer, so it was a Go Temp. But yes, it would be an Easy Temp that plugged into the CE. I had a Go Temp that plugged into my computer, which is an Easy Temp, but with a big USB.
Okay.
Gotcha. Thanks for that clarification.
Right. But then you can also, with the computer, get the Easy Link. I mean, the Go Link, which the Go Link will allow you to plug any of the white tip sensors that are the analog sensors. The motion detector will not work with that because that's a digital sensor into the computer.
Thanks. Part two of Harriet's question was where she could buy these and how much they were. And so on our website, on the right-hand side, there's a where to buy. And so you can figure out which one of those three works best for you, but probably the ready to purchase, contact a dealer. So there's obviously lots of dealers that are going to be able to give you different pricing, and so you can feel free to contact any of those to get more information. The other thing I want to bring up at the very bottom of any of the web pages on our website is Contact TI. And I saw that, I believe we have Rob Wilson on tonight, and he is a great example of TI sales support. So right in the middle, if you click on TI sales support, looks like Rob Wilson. Rob Wilson covers a few different states, and he's a great example of someone that, in my opinion, is a great intermediate in between what you might need or want in the classroom and text instruments and what they have to offer. So I know a lot of times these educational technology consultants can either do demonstrations or certainly answer questions or point you in the right direction and get you in contact with people if you have questions about certain specific things, such as some of the questions that maybe were asked tonight. So please feel free to visit the bottom of any of our web pages and the Contact TI tab and find your local educational technology consultant. I personally have found mine to be really useful over the years, and so please feel free to reach out to them anytime that you have any questions. Also, before the webinar, Judy and Jackie and I were talking about how easy it could be sometimes to find some of these activities on our website. And so just to make sure everyone's on the same page with that, at the very top, again, there's an Activities tab. And if you slide down to All Activities, it's really helpful if you know the name of your activity. So for instance, I believe tonight we looked at an activity that had the word MOS in it. And so if you type in the word MOS, it looks like there's two different activities that are available, one being for the TI-83, 84 plus family, which we certainly use tonight, and the other being for the TI-Nspire family. So please feel free to find some really great activities that are available for free on our website. Last shout out on our website is under the Professional Development tab. and near the bottom there's webinars and tutorials. And so some of you may be familiar that we do a lot of these webinars on Tuesday nights. We also have a specific calculus thread that just started running a few weeks ago on Thursday nights. So every now and then on Thursday nights, we're also doing a calculus-specific webinar. This coming Thursday, we're going to be doing a webinar that focuses on using computer algebra systems, or CAS, in teaching calculus. So if you want to know more information about that, or you have no idea what a CAS is, it might be a great webinar for you to attend. And so you can go over to the live webinars on the lower left-hand side, and feel free to register for the teaching calculus using computer algebra systems link there, or any of the other webinars that we're going to be giving this coming fall. The nice thing about registering for them is even if you can't make it for one reason or another, you automatically get a follow-up email with a link to the recording, a link to the documents, and a link to the certificate as well. And when you leave the webinar, a brief survey will automatically appear in your browser. We definitely listen to your feedback, and we really hope you share your thoughts in that post-webinar survey. As mentioned earlier, tonight we're giving away to one lucky winner a T-Cube International Conference registration. Tonight's lucky winner is Nancy Cosera. So Nancy, congratulations. We'll be in touch over email in the next couple of days. Really hope to see you as well as everyone else at the T-Cube International Conference. If I was a betting man, I would bet that both Jackie and Judy are probably going to be at the International Conference this year and presenting lots of great science, data collection, 84 material is my hunch. To receive a certificate of attendance, please click the link in the chat window. Also listed is a link for the documents that were used tonight, as promised. And if you happen to miss these links or they're not working for you for one reason or another, have no fear, you'll automatically get a follow-up email in a couple days that, again, will have a link to the recording, a link to the certificate, as well as a link to the documents. And if you happen to be watching this on our on-demand, please feel free to copy that link down into your favorite browser to receive your certificates. Again, we hope we answered your questions tonight, but in case we didn't or you have any questions after the webinar, please feel free to reach out to us, give us a call, or send us an email. Thanks so much, Judy and Jackie. I think that there were some really great things that were shared tonight and lots of great comments and questions. So thank you so much for sharing your expertise with us.
Thank you so much for asking us.
Thank you, and have a good evening. And those who are in the path of Matthew, be careful.
Yes, absolutely. We'll be thinking about everyone, and we really hope to see everyone back online later this week. Thanks so much, everyone. Have a great night.